Managing airline operations on the day of travel is a high stakes puzzle. A storm, a ground stop, or a late inbound can ripple across the network, affecting crews, gates, passengers, aircraft, turning small delays into a network wide disruption. Profitability and customer satisfaction hinge on how quickly and effectively an airline can recover from this. My name is Varun Bhamidi, and in this demo, I'll walk you through how an operations manager at Brick Airlines Network Operations Center can leverage the power of an integrated platform to quickly identify an issue, run what if analysis, compare the various recovery options, and trigger a coordinated execution, minimizing costs while keeping customers happy. Now, what powers this is the strength of a governed data, AI, and application platform like Databricks, enabling ideas to move from concept to production in weeks instead of months and years. Imagine you are the network operations manager at Brick Airlines and you are watching the network operations dashboard. A real time alert pops up telling about a runway closure in LAX. You click on the details to see the flights that are affected, the passengers, and the estimated cost if no action is taken. You click on the details to look at the individual flights, and then you are provided with an option to run a simulation or a what if analysis to see how you could recover from this event. The simulation comes back with 4 options, with each option weighing in as a trade-off between cost, on-time performance, NPS score, and load factor. First one is a cost-optimized solution, which does reduce the cost of recovering from this event, but it has to, the price you will pay is mostly on the on-time performance and NPS score. The second one is a customer experience first solution, which is to reduce the impact to the customer and making sure the on-time performance remains good and the NPS score stays high while it does incur a little bit of cost to the airline. The third one is a little bit of a balanced solution, weighing in both cost and fast recovery. And then the fourth one is more on network resiliency, which is saying how do we have the minimum impact across the network. As a network operations manager, now you can go and review what are the recommended changes for each of these options. For example, for this cost optimized solution, the recommended changes and the actions are talking about retiming certain aircrafts, bringing in a reserve aircraft allocation, also talking about a crew swap and a grade reassignment. You review all the changes, validate against previous recommendations and things how this was done to recover from this. And once you're satisfied, you can send this for approval. What that does, sends this information into an inbox where you can you can view all the changes and the impact across the network, not just for this specific change. Once satisfied, you can click approve, triggering a coordinated execution, bringing in crew coordinators, flight dispatchers, maintenance teams, gate agents, and customer service teams all on the same page, ensuring a faster, more synchronized recovery. The platform also provides a way for you to look at all the simulations that were run, as well as all the optimizations that were applied, the decisions that were sent for approval, and the decisions that were actually accepted. And you can tie all of that back to the total cost savings that the airline had. Now you must be wondering, how do we trust some of these recommendations? Now this is where the power of an integrated and governed data, AI, and application platform like Databricks really comes to life. Each recommendation can be traced back to see how the recommendations ran through the various optimizers and solvers and how they were leveraged, including details at each level. You can look at the version, you can look at the data sources that were applied, all the dependencies, as well as the outcome. This lineage adds trust to the actual output that is being provided. You can also look at, for example, the input data sets that were used. You can see what were the actual data that was actually leveraged in order for this event or this recommendation to be provided. You can also go dig into the specific details of the input and output schema. To summarize, what I showcased today is a hypothetical scenario of a disruption containment and an irregular operations scenario for an airline, illustrating how an integrated platform that unifies data, AI, and application within a governed ecosystem can enable teams to make faster, more informed, and trusted decisions while improving coordination across business functions. I want to acknowledge that in reality, these situations are far more complex than what this demo represents. The goal, however, is to highlight the art of the possible. Thank you for your time. Hope you found it useful. Would love to hear your feedback.